session of the 14-part Microsoft SQL Server 2014 launch webinar series. Over the coming weeks, the past virtual chapters will be hosting various Microsoft speakers from the engineering and technical marketing teams who will discuss new functionalities and enhancements in SQL Server 2014. Before we get started today, I wanted to share some information about PAS and tell you a bit more about the Security VC and our future meetings. For those of you who may be new to the Security Virtual chapter, let me take a moment to introduce you to PAS. PAS is an independent, not-for-profit organization run by and for the community. PAS's membership is growing with more than 100,000 members worldwide. The organization supports data professionals who use the Microsoft data platform to connect, share, and learn through virtual chapters, offering free online training such as this one, in-person events including the PAS Summit, Business Analytics Conference, and regional events including SQL Saturdays and SQL Rally. Visit the PAS website at sqlpass.org to find out more. As a valued member of the Security VC, we're extending a $150 discount to the PAS Business Analytics Conference taking place May 7th through 9th in San Jose, California. Just use the discount code BAVC24 when you register. The conference offers over 70 sessions by the world's top business intelligence and business analytics experts and over 20 hours of networking opportunities with 1,000 data professionals from around the world. You'll walk away with real-world insights from companies such as Microsoft, Wells Fargo, SurveyMonkey, Yahoo, and Intuit, as well as best practices, prescriptive guidance, and strategic vision. I highly recommend you find out more today at pasbaconference.com. If this is your first Security VC meeting, make sure to join us again soon. We publish our schedule on our website, security.sqlpass.org. All meetings are recorded and archived for future viewing on our website. Now, I would like to introduce Evgeny Krivoshev, who is going to talk to us about buffer pool extension and resource governor for I/O. Thank you, Evgeny.
Thank you very much. So as it was mentioned, I will be talking today about the buffer pool extension and resource governor for input-output features of the SQL Server. Okay. So the first feature I'm going to talk about would be the buffer pool extension. Let's take a quick look on how Buffer Manager works in the SQL Server. So Buffer Manager is effectively the manager of the memory pages that SQL Server uses for almost everything which is inside the SQL Server database engine. There's some memory regions which are used differently, but this is for sure the largest memory region located by the SQL Server and one of the most heavily used memory regions by the SQL Server. So as you can see, when you request starts, this TDS protocol which lands at the protocol layer, which processes it, passes it to command parser, and it goes to the relation engine where it goes to the optimizer or query executor after the optimizer. And in all those cases, relational engine starts to operate with the pages. Pages is an 8 kilobyte memory block that's consistently used by the SQL Server for the data storage. So when data is retrieved, it's retrieved from the storage engine, and results also sent back to the storage engine in the same format, 8 kilobyte memory pages. So if there is a transaction log, it also operates with pages. And finally, there's a buffer manager whose responsibility is to manage the memory part of that's 8K pages allocation. So what buffer manager does, it makes sure that there is enough free pages available for the storage engine and for relational engine, and it also makes sure that if something is getting retrieved, it has the correct attributes and so on. So what the feature we implemented here is doing, so we basically implemented something similar to what you have in Windows in your page file. So we implemented special caching capability that allows you to extend your buffer pool and place part of this buffer pool to some fast storage device like SSD drive. In that case, you can have larger buffer manager. Larger buffer pool, and buffer manager effectively hides that complexity from the rest of the SQL Server. So actually nobody except buffer manager knows that there is a buffer pool extension. So all parts of the SQL Server are operating as they have been doing before. So let me talk a little bit about why we decided to do that thing, and what were the most critical parts of that decision making. First, we saw that customer has demand for applications that need to improve the performance of OLTP queries, and that's one of the most complicated things from this database engine point of view. So we are constantly looking how to improve that, and that did look for us as a kind of good opportunity to improve the performance. At the same time, we know that SQL Server is mostly constrained by the I/O, because we're working with the database, and database is usually way larger than the memory amount that people have on their machines. So, and to overcome that, the SQL Server uses different techniques to cache the data, and the buffer manager is one of those techniques. So what we see is that buffer manager itself may be not enough to cache really large OLTP databases, and people may become constrained by their memory resources, and despite their machine can deliver more performance and more value for them, they're still limited by the memory amount, and upgrading that memory may become a big problem for them. Sometimes that's limitation by the platform, and sometimes that's just very expensive. So we also saw that there may be situations when people don't want to increase the memory amount just because they don't want to shut down their database server for some maintenance period. At the same time, usually adding new storage devices is online operation that doesn't require any downtime from the hardware point of view, and that gives customers some freedom in what they can and what they cannot do. So what we did in a SQL Server 2014 for buffer pool, so we introduced the feature that called extension. So as I mentioned already, the buffer pool is the most widely used part of the SQL Server memory management. It's the largest memory block in a SQL Server, which SQL Server gets the most benefits from when it increases, because if there's any memory pressure, it's basically in that block rather than in other blocks, because this is the biggest blocks, and it's biggest with really huge difference from other memory blocks. And this is the most critical part of the SQL Server memory to reduce the I/O pressure that SQL Server constantly experiencing. So buffer pool extension allows you to use any kind of non-volatile storage devices to increase the size of your buffer pool to increase the amount of memory that's available from buffer pool to consumers of the pages. And this effectively allows usage of devices such as SSD as an intermediate buffer pool storage and getting the price point down to make sure that your solutions are not as expensive as they could be if you only rely on memory. So how buffer pool is working and how buffer pool extension is working. It's there are two kind of pages we are operating with. We call them clean pages and the dirty pages. And the clean page is is a page which is identical to what we have in a database file already. So it may be just read from the database. Maybe it was read a long time ago, but nobody has been changing it, or it was recently committed to the database file or to the log file. So in all those cases, that page would be considered clean. The opposite for a clean page is obviously dirty page, and the dirty page is a page which has changes which haven't been written to the database yet. So it hasn't been committed to the database yet. The buffer pool extension only stores the clean pages. Why that's important thing to mention? Because it gives you as few advantages as some limitations. For example, clean pages make sure that you don't need to worry about the about the health of the device where you store your buffer pool extension, because any failure on that device would not lead you to any of the data loss. We can just abandon that buffer pool extension without losing anything. At the same time, it's clear that when you're operating mostly with you're caching mostly the clean pages, you will be getting the most benefits from the read-heavy workloads rather than from the write-heavy workloads. So it's somehow limits the choice of workloads which will benefit the most from that feature. Let's talk a little bit how we actually do the eviction and how we select pages which should go into the extension and which should stay in the memory. In the past era, before the buffer pool extension, we had a notion of pages which are cold and hot. The hot pages, the pages which are available in the memory, and the cold pages were the pages which are in a database storage. So it's kind of harder to reach pages for us. With buffer pool extension, we introduced the intermediate thing which is called warm pages, and those are pages which are in a buffer pool extension. So what we do based on the memory pressure and a buffer pool extension pressure, we constantly calculating two types of threshold. We call them upper and lower threshold. And when a page became close to the upper threshold, we consider that page for eviction into the warm pages area. This could mean one of the two situations. So either page is already in a buffer pool extension. In that case, we will just abandon that page in the memory and we'll reuse that memory amount for some other page. Or if that page is not in a buffer pool extension yet, we will first write it to the buffer pool extension and then evict it from the memory. And of course, similar situation happens when we feel that there is a lot of pressure for the extension part, and then we start evicting pages from the extension. But for extension, we don't need to worry about writing any pages because all pages in extension are clean. So we only abandoning pages when we feel there is a memory pressure. So the feature configuration is a very simple. This is formal definition of the DDL for the SQL Server, and as you see, there are very few parameters that you're defining when you're enabling that feature. The parameters is a file path is a size, and that's basically all that you can define when you configure the feature. And it's also important to keep in mind that there is no way for you to reconfigure the feature once it was enabled. You need to go and disable that feature first before you can reconfigure that. The main reason for that because buffer pool extension is usually larger than the memory size that you have, and there's if you're using it long enough to allow it to ramp up to the speed, it would mean that you have a lot of performance that relies on that feature, and any reconfiguration would mean that we will turn things off internally and then turn it back on. That could drop the contents of the extension file, and that could leave you in a state when the performance after reconfiguration of the feature would not be something that you had just before reconfiguration. So we decided to keep that operation as an explicit operation, so you would know that if you would turn that feature off, you will see the performance drop. So you see that. It's not an implicit, it's an explicit operation. And as also the slide suggests that in order to configure the feature, you need to have the permission to alter server state, because it uses the alter server configuration statement. Let me quickly go through the few examples of how you can configure the feature. And the first example is showing pretty simple statement is how you can enable the feature, and it shows how you can enabling it with 50 gigabytes size. And then next, let's move to the situation when you're saying that the size configured for the feature is maybe not enough. And in that case, as I have just mentioned it, you need to go and change configuration of the feature to turn it off. I'm not sure if you see my cursor, but I'm trying to show that section on the slide. And also you may want to go and change your maximum server memory amount available for your server. For maybe that's increase, maybe that decrease. Then you do the reconfiguration that's required for ESP configure, and then you again re-enable that feature with a larger memory size. And that's another important thing I would like to mention about the feature, that the minimum size for the extension file is the same size as is configured implicitly or explicitly for your maximum server memory. So if you have 32 gigabytes of maximum server memory available for your SQL Server, you cannot set buffer pool extension smaller than 32 gigabytes. However, you can set it larger, but once you set it, you cannot decrease the size of the extension file until you restart your SQL Server instance. So you can only grow it. It's that limitation is due to some internal things that we're doing, and that's those things were done for performance reasons. So those are some performance optimizations that set those limitations. We actually haven't heard from any customers that this is a big problem for them, but just to make sure that you know that if you would like to reduce that feature configuration size, you need to restart your SQL Server instance. Also, we added some changes in the SQL Server that allows you to control the configuration and see how the feature actually behaves. For configuration details, we have added the view which is called sysdmos buffer pool extension configuration, and as I have mentioned, the feature is limited to the size of the maximum server memory, and that should not be. It is not allowed to configure it to the smaller amount that it was configured before. And one last thing to mention here is that for managing buffer pool extension, we're reserving some relatively small amount of memory, which we are not returning until a SQL Server instance restarted. So if for whatever reason you think you are constrained by that memory block that was reserved for buffer pool extension management, the only way for you to get that memory block back is by restarting SQL Server instance. But at the same time, if you just enabled your buffer pool extension and disabled it back, for example, you probably will not lose any memory because we only do the reservation of the memory and we are not committing it immediately. So actually it's just some record in the OS memory structures that says, hey, somebody said it may need that memory. It's not like we started to use that memory, and we haven't actually committed that memory. It's available for other applications and for other users of the SQL Server. Some other DMVs are the following. So we changed the buffer descriptors DMV, where you can now see which pages are actually in the memory and which pages are actually in the extension file. So you can clearly see up to the lowest details what's inside your memory, what's not. Also, we added 4 Xevents that allows you to capture situations when we write pages, read pages, evict pages, and when we recalculate the page eviction threshold. Also, we added few performance counters that allows you to see how your buffer pool extension feature is behaving. And there you can obviously see your device-related statistics like reads and writes. You can see your outstanding I/O counter. Actually, that you will see it in any noticeable value for this SSD device, but yes, it's still may be useful in some corner situations. There are page evictions, which are effectively showing you how much memory pressure do you have and how much of memory pressure reflected in the buffer pool extension activity. There are allocated pages, which is basically, okay, how many pages I have in my extension. Free pages, page unreferenced time, which is what happens until we finally clean up the page, and the usage of the extension file as a percentage of the total allocated pages. So you can see how effectively you're actually utilizing your buffer pool extension. And let me summarize a few things about the buffer pool extension. So use of the SSD is cheaper than using just a dynamic memory to reduce the SQL Server memory pressure. And SQL Server memory is a critical part to reduce your I/O pressure. And I/O in turn is the most critical part for your overall SQL Server performance. The second thing to mention is that there is no risk of data loss because we only work with the clean pages in a buffer pool extension. Next thing that I would like to mention that internally, using internal tests, we observed up to 3 times performance increase for OLTP workloads. And clearly, I cannot just say that you will see the same performance improvement. And because in all cases in SQL Server, your performance depends on the workload that you're running, so you're encouraged to test your workload before you decide how much performance gain you can get from it. But this is what we saw. It's kind of gives you some idea of how much performance you could expect in some ultimate situations. Oh, sorry.
We have a couple of questions for you, Evgeny.
Yeah, sure.
The first question is SQL Azure WASD using BPE, and was this feature developed to support WASD?
Could you say it again?
So is Windows SQL Azure Database using BPE, and was this feature developed to support it?
So this feature is kind of hardware level feature. So we don't separate if it's for SQL Azure or if it's for the box or for any other deployment of the SQL Server. SQL Azure is kind of special, slightly special animal of the SQL Server, so it has its own set of settings, and it's deployed in configuration which is not available for the box, so it's a kind of tricky thing. I don't know if they took immediate dependency on that or not, but I know they have been actually discussing that.
The other question is, do you have any guidelines for flash storage performance in terms of sequential read throughput and random read IOPS for BPE usage?
So we don't have any kind of ready-to-use guidance, but the lower latency you would have on your SSD device, the better total performance you will get. Basically, the closer your SSD performance to your memory performance, and the more far away it's from your spindle performance, the better performance will be the total performance.
All right, sounds good. Sounds good. Those are the two questions that I had.
Sure, let's go with them. What?
No, I'm sorry. I meant that those were the questions that we had. So please move forward.
Okay. Yeah, and as I mentioned, sorry, there is an error in this that deck that it says that feature is only available on SQL Server Enterprise, but actually it is not only available on SQL Enterprise, it's also available on SQL Standard. That's one of the changes that we did for that feature at the last moment, so I forgot to update that slide. Another thing which is important to mention that despite the feature allowing you any size of the extension file compared to the memory you have, and that size range is from 1x to 32x, we kind of observed that sweet spot in a range of 4 times to 10 times of your memory size. It's not like you will not get more performance if you will get more SSD, but probably it will not be as huge increase as if you will be trying to select this SSD size in that range. And another thing which is important to mention, that if you have data warehouse-like workload, don't expect performance improvements. And we saw a few customers who have been trying that feature who the first thing they have been doing is to doing select start from some table, and in that situation SQL Server thinks this is data warehouse-like query because this is basically table scan from the SQL Server database engine point of view, and in this case buffer manager has some special handling for those queries, because we know that in majority of data warehouse workload situations, the data size is really huge, and it will be able to wash out any cache size we could offer for the customer. So in this case, we're only caching some very limited metadata set. So you will not get any visible performance improvements if you're really running data warehouse-like workload. It's mostly for the OLTP workloads. So before we will move on to the next feature, if you have any questions, you can ask them here, or you can postpone it until end of the session. I think we will have some time at the end.
We have no questions in the queue,
Okay, great. So the next feature I'm going to talk about is the resource governor, and that resource governor feature was implemented also for the I/O operations in the SQL Server. So let's talk a little bit about the resource governor architecture and what it actually does. And first, let's start from the your request. That's kind of red part of the picture. And when your request came, it is associated with some attributes that may be uniquely identifying your request or your workload type or query type or something like that. And then it goes to the classification function. And classification function is supposed to be some function that was created by customer. This is usually pretty simple function, and we have examples of those functions in the MSDN and the books online, so you can just grab one and modify it. It will not be hard thing to do, and this is not something new we have for that feature. And then that function is needed to characterize your workload and bucketize it into the different groups which you are defining. Those groups then associated with what is called resource pools, and resource pools are set of resources together with some limitations associated with those groups of resources. So you may define that you have a CPU resource and you would like to dedicate so much CPU for your queries. So that would be your resource pool. And why we did that change for the resource governor? Because we know that I/O pressure is one of the hardest problems for people who are running SQL instances which are consolidating different type of workloads. People prefer predictability in almost all cases, and the resource governor initially was designed to give that kind of peace of mind for customers, to give them more predictability of the query execution. So we decided to extend buffer, resource governor to that I/O side of the SQL Server. So, as I mentioned, there were few resources that you can associate with the resource governor before. It was CPU, it was memory, and for CPU it has been allowing you to affinitize things to different cores. It allows you to hard cap the CPU and set the minimum and maximum. So, as I started to discuss already, there was few reasons why we have been considering governing the IO using resource governor. One of the key things is to make sure that there is enough isolation between different types of workloads, and so this keeps those workloads operating as they're expected to be operated by the customer. And especially that's important for situations like consolidation or hosters who hosting different types of workloads, and not all those types may be same workloads, and they may be interfering with each other, especially given that I/O is usually very limited resource, and so storage devices may be very restricted in terms of what they can deliver. And also we would like to provide customers the complete view of the governance feature for the SQL Server. Resource Governor had a memory and CPU limiting capabilities before, but it haven't had an I/O, and it was kind of clear for everyone that I/O is maybe even more important part of the SQL Server resources available, so we decided to go and extend it here. And this is more or less equivalent as for situations like your SQL Server instance running on a physical machine, some as on a VMs. And this is also a very important thing for situations like running your SQL Server in a cloud VM, because in the cloud your I/O may be also very constrained, not in terms of individual items, but in terms of latencies, and you don't want to have any kind of I/O spikes. You probably would like to have more steady I/O. So let's talk a little bit about what we actually added for the configuration part of the resource governor. As I mentioned, we added ability to restrict the IOs per volume per resource pool. So you can set the minimum and maximum amount of IOPS available for specific resource pool. And also we allowed you to configure total outstanding I/O per volume, and that helps you to keep your storage volumes in a good shape, even if you maybe slightly overestimated it has in each individual pool configuration. That setting will help you to make sure that you are not overloading your I/O and your I/O is not constrained and not creating your additional bottleneck, because when I/O is already constrained, especially for the spindles, this could cause any additional I/O restrictions, so your total I/O performance may be dropping even bigger from normal operation. We also did some changes to how you can observe what is configured, what is actual performance, and so on. So we added new columns to the resource governor resource pools, and those new columns are showing you maximum I/O available, read-write queue, how many styles, how many policy violations, and also we changed the resource governor configuration part, and it shows you I/O stall and read-write latency. And we added the new DMV, which shows you resource pool volumes, because as I showed on the previous slide, let me quickly go. Now we have outstanding I/O per volume, and this is basically showing you how your different volumes are operating and what's their performance in terms of read-write queries, how many and how many violations, policy violations are happening here. Also, we added 2 new Xevents to trace how your I/O requests are going through the resource manager queries, and those are file write enqueued and file read enqueued. And you can use them together with an existing events of tracing I/O, like file read write and for file write and other I/O completion things. Also, we added 6 new performance counters, those allowing you to write to track reads and writes for IOs and for bytes. And this also allows you to track the latency of your I/O. So actually, that's all that I have for the resource governor, and I think it's probably a lot of questions from your side about the resource governor and probably about the buffer pool extension. So I would be happy to answer those.
Right now, I'm not showing any questions, but please, folks, feel free to ask them. Go ahead. Folks, if you have any questions, this is the time to ask them. All right, you can, if you want to wrap it up, then.
Yeah, sure. Okay. So I'm passing that to you back, Arjun. So thank you very much for attending. And if you have any questions, you can direct them to me or to the past virtual chapter. I will be happy to answer those in the future.
All right, well, thanks everyone for coming to today's presentation. We appreciate your attendance. And feel free to send any questions you may have to securityvc@sqlpass.org, and we'll be happy to forward those to our speaker today. And you enjoy the rest of your day.